The last lecture we have started with the numerical solution to ordinary differential equation, and then we have solved the differential equation using Euler's method. Okay, in Euler method, we know that error is not considered. We just go on calculating to the next step and next step onwards. Now we need to understand the Euler's modified method, where we do care about the error, and then we move on with more accuracy. Okay, so let us try to understand this. So I hope you are able to see this. Yep.
Yes, sir.
Okay, that's good. Okay, so now we'll go with the Euler's modified method. Okay. Okay, some people also call this as modified Euler method. So what we have here, we have a formula. Suppose we have dy by dx is equal to f of xy with the initial conditions x0, y0, and the step size h. Okay, then we have, so what we have, the y1 is given as y0 plus h times f of x0, y0. This formula is called as
Predictor formula.
predictor formula, right? Okay, and then we have, and what will be having? Please be careful for the notation. You should not change the notation. It should be written as I am writing only. Okay, so it is the first approximation to y1 or first correction to y1. So here we are getting y1, but that is again an approximate value. We want more accurate value. So that's why this is going to be the first correction to y1. Okay, and what is the first correction to y1? So it is y0 plus h by 2. Here we have f of x0, y0, and plus f of x1. So in Euler method, we do not use x1 to find y1. We use x0 to find y1. But here we want more accurate answer. So we use x1 to find y1. Okay. So x1 and this is y1. So we use the previous position and the current position, that whatever we have got. Okay, and we know what this formula is called. We are correcting with this formula. So this is called predictor formula. Okay, so we have a predictor formula and we have a corrector formula, and we go on correcting, okay, till we get the accurate answer. Okay, so once we get the accurate answer, then we stop. Okay, so here this is the difference between the Euler method and modified Euler method or Euler's modified method. We improve the accuracy in modified method. In Euler method, we don't think of the accuracy. Okay, so here we are going to improve the accuracy every time. Okay, so is this idea clear?
Yes, sir.
Okay, that's good. Okay, if your idea is clear, okay, then we can try one example so that you can understand how this modified method works. Okay, so let us try only one step. Okay, and then we'll go to the more than one step. Okay, so in Euler modified method, usually we go with the 2 steps. Okay, so final answer we try to find in 2 steps. But here we'll first try to understand how the accuracy is considered, and then how we are able to get the answer. Okay, within one step. So let us try to solve one problem using the Euler's modified method. Okay, so here we have the problem. I hope you are able to see this.
Yes, sir.
Okay, so we have to find y when x is equal to 0.05 by Euler's modified method, taking h is equal to 0.5. So you can see x is going to be 0.05 and h is also is going to be 0.05. So we can find in one step. Okay, so let us try to understand how this method works and where we have to stop. Okay, and then we'll go for two steps. Okay, so here we have to find the answer in one step. Okay, so let us try to find. So what we'll be having here, let dy by dx is equal to x square plus y with y at 0 is equal to 1. So that is, from here we need to understand what is x0 and y0. So this term is going to be x0. So we got here x0 is equal to 0 and we got y0 is equal to 1. So y0 is what? Y at x0 is going to be y0. That's why we got y0 is equal to 1. H is already given, so 0.05. Okay, and we have the function. Okay, so what is the function we have? Function of xy. Okay, so it is going to be x square plus y. Okay, so we have these all given things. We have a differential equation. We have the initial condition. So this is going to be an initial value problem. Then what are the initial conditions? We have x0 is equal to 0, y0 is equal to 1, and the step size is given to be 0.05. And we have to find the value of y at x is equal to 0.05. Okay, so we need to use only one step. Okay, so here what we can say is by Euler's modified method. Okay, we get. So what we are able to get is, first we have to calculate we have to use the predictor formula and calculate the first approximate value. So we have y1 is equal to y0 plus h times f of x0 y0. So what this value is going to be? Y0 is going to be 1 plus h is going to be 0.05 and f is what? X square plus y. So it is going to be 0 square plus 1. So this is the function x square plus y. So we got here x0 is 0, y0 is going to be 1. So it is going to be 0 square plus 1. So what we will be getting, is that okay?
Yes, sir.
Are you getting this one? So y1 is equal to 1.05. Okay, again, this is going to be the approximate value as we have used the predictor formula. Okay, so what we use here, we use the predictor formula. Okay, now think of the correction to this term. Okay, so now we know the value is nearby 1.05, but we have to improve the accuracy of this value. Okay, and hence we have. Okay, so the first correction to y1 is equal to what we have here. This is going to be y0 plus h by 2, and here we have f of x0 y0 plus f of x1 y1. Okay, and that is equal to, what do we know? This y0 is going to be this is the corrector formula. Okay, this is going to be the corrector formula. So y0 is going to be 1 plus h is going to be 0.05 and this by 2. F of x0 y0. So f of x0 is 0 square plus 1 and this value. So x1 is going to be 0.05. So it will be 0.05 square and plus y1. Is that okay?
Yes, sir.
It will be x1 square plus y1, no? Okay. So now we simplify this 1 plus 0.025 and this is going to be 1 plus what will be the value of this? Is it 0.0025? Is that okay?
Yes, sir.
So what this will be? 1 plus 0.025. Okay, and this will be 1.0025 plus y1. So how we can make this calculation faster? Okay, so we got here 1 plus 0.025 and here we have 1.0025 plus y1. Okay, so take out your calculator and type this equation. Okay, so 1 plus 0.025. Okay, use proper brackets and this will be 1.0025 plus the button you have to use is alpha. Okay, and then you have to use shift. Okay, and then you can find there either it will be a bracket or it will be, so you have to type it y. Okay, so that's how you have to write this equation, okay, in your calculator. So this you can do faster way. So you can go for approximation in a faster way. Otherwise, every time you have to write this equation. So are you able to get the equation like this? 1.002 1 plus 0.025 and this will be 1.0025 plus y. This should be displayed on the display of a calculator. Are you getting this on the display?
Sir, can you repeat that? How to write that?
Yes. So these numbers easily you can write, right?
Yes, sir.
Okay. So press the button alpha. So it gives you alphabets. Okay. Then you can see Y in yellow or in other color. As you can see X, you can see Y also. You can see the bracket, the closing bracket is X and next to that is Y. So you can use the shift and that closing bracket as X, shift and that button as Y. So your display should be like this. So your display, calculator display will be displaying this equation. Are you getting this on the display?
Yes, sir. Yes, sir.
Yes? Okay.
No, sir, I didn't get.
Okay, you are not getting. Okay. I hope all of you are using the 991 calculator. Okay, so are you using 991 calculator?
Yes, sir.
Yes. Okay, so you can see near the shift, okay, there is one button alpha, which is written in the different color. Are you able to locate this button alpha? Yes.
Yes.
Okay, so to get Y, what we have to do is press this alpha button. Done with the alpha button. Have you pressed alpha?
Yes, sir.
Yes. Okay, now you can see press shift.
Yes, sir, I have pressed.
Okay,
Sir,
and
but
now
you
you can see the conversion between yes and D, that is simple fraction and decimal fraction.
Yes, sir.
So you can press that and you can get Y on the display. All of you got this one? So ultimately you have to get this equation on the display. Have you got this equation on the display?
Yes, sir.
Okay. So if you can do this, then you can go faster. I'm giving you a technique which will make your calculation faster. Okay. So we got this equation. Okay. The So you got this equation. Now I'll tell you how to calculate. Okay, so there is a button below shift. Okay, cal C. Okay, there is a button below shift cal C. Are you able to locate this? Okay, so here it is button cal C. Below the shift button, you have a cal C button, right?
Yes, sir.
Yes. Okay. So once you got that button cal C, press the button cal C. What is happening? Tell me.
Sir, it is Y question mark.
Yes, it is Y question mark. Okay, so Y question mark, okay, means what? Okay, it is asking you the value of Y. Okay, Y question mark means what? It is asking you the value of Y. So what we have to do now? We have to input this value 1.05. What we have to do is we have to input this value 1.05. Okay, so you can have the first correction to Y1. Okay, so we'll be having here. So this is 1. Okay, 1 plus okay, so it is 1.0025. Okay, plus alpha shift Y. Okay,
So we get 1.0513125.
yes. So when you put this value, okay, you are able to get is 1. What you are getting? What is the value you are getting?
So
1.05.
1.0513125.
Yeah,
Same, sir.
I'll write here so that 1.0. What you got?
1.05
1.05
13
13
125.
125. Okay, so all of you check this whether you are getting the same or not.
Yes, sir. Same.
Okay, all of you are getting same.
Yes, sir.
Okay, so if you are getting this value, now you can see the correction. Okay, so it is earlier it was 1.05 only. Now we got the correction 13125. Okay, so this is the first correction you got. Okay, now next correction we want. Okay, so we have to go to the next correction. So what will happen? See, y1 and second correction. So what you got here? We have to write y0 plus h by 2. And here we have f of x0, y0 plus f of x1, y1, 1. Okay, so that means the recent value that we have got, we have to use it. Okay, but how to do this in a faster way? So you can write y1, okay, y1 and second correction. So how do you get this value? Now again
So-
press LC button. Now
So I have
again
a
press LC button. Yes.
question. So in the exam, do we just do we have to write it like this, or we can just use the calculator to do a second?
Yes, you can directly use a calculator, but I'm telling you how we are getting that second correction.
Okay, sir.
Okay, so this is the formula for the second correction. Okay, so that means first correction we have, and we are using this first correction. Okay, so this way we will get the second correction. But what you have to do, you can directly press Cal C. So all of you, please press Cal C button. And now again, it will ask you what is the value of phi, right?
Yes, sir.
And
Yes,
now,
sir. We get
yes, now you have to reuse this recent value.
yes, sir.
Okay, so instead of 1.05 only, you have to use 1.051325.
So we get a value 1.0526
1.0526
2693.
93. That's sufficient. 6 digits. Okay, so is there anyone who is getting different value?
Excuse me, sir. I'm getting another value.
Okay, okay. What is the value you are getting?
Sir, I'm getting like 1.05134531.
134.
Yes, sir. Same.
Yes, sir.
53.
Same.
Yes, sir. Same,
12.
same value, sir.
13, sir.
You are getting this value, right?
Yes, sir.
Not this one.
No, sir.
Okay. So what most of you are getting this value, right? Most of you are getting this value, no?
Yes, sir.
Okay. So we'll accept this value because most of you are getting this value. Okay. So you can see now how accurate this value is. Okay. So earlier we got 1.0513. So you got here 1.0513. So actually it is accurate up to 4 digits. Okay. This is accurate up to 4 digits. Okay. So if you want, you can stop, or if you want to get a more accurate value, we can go with more one more iteration. So we can go for the next correction. So we have the third correction to y1. So you can again press Cal C and use this current value. Okay, so press Cal C and use this value and get the value, next value. What we get?
1.05134.
Or
6.
6. Okay, so you can see now what is the accuracy. The accuracy is improved to 10 raised to, this was 10 raised to 4, and this is improved to 10 raised to 5. Okay, and so on. If you go on taking more and more iterations or more and more correction, it will remove the error. Okay, so you can see earlier the value y1 that we have got by Euler method is 1.05. Okay, and this is the value what we have obtained by modified Euler method, or Euler's modified method. That is, this is more accurate. So here there was a error. Okay, this was error, but now we have improved that error and we have removed that error actually. So this answer is most accurate answer. Okay, this answer is more accurate answer. So we can say here, hence by Euler's modified method, we get y is equal to 1.051346 at x is equal to 0.05. Okay, so this way we get the accurate answer. Okay, and this is in one step. Okay, we have solved for one step. So you got the idea how the Euler modified method is improving the accuracy. So Euler method is giving you the value. It is predicting the value, and that is going to be 1.05. And then this modified method is correcting that value. Okay, so 1.05 was the predicted value, and now this modified method is correcting that value, and it is correcting. So here we stop with 10 raised to -5 accuracy. Okay, but we can go further. Okay, so we can improve it up to 10 raised to minus 10, 10 raised to minus 30, and like that. The accuracy, whatever we required, we can improve up to that point. So is there any doubt in this example? Is there any doubt in this example?
No, sir.
No, sir.
Yes. Is there any doubt?
No, sir.
Okay. So all of you got this example. Yeah, you got this example.
Yes, sir.
Sir, I am getting value of y negative.
Negative.
Yes, sir.
Okay. So I'll suggest you to please check your calculation once.
Yes, sir, I will do that, sir.
Yes.
Yeah.
Please check your calculation once. Okay. And then let us see.
Yes, sir. Thank you, sir.
Yeah. Welcome. Okay. So if you are done with this example, let us go to the next example. Okay. Again, we'll see in one step. We'll apply this method for one step, and then we'll go for two steps. Okay. So I'll go with the example. Okay. So I hope you are able to read this example. Are you able to see this example?
Yes, sir.
Okay, that's great. Okay, so what we have here, see, solve this differential equation by Euler's modified method for x is equal to 0.1. Okay, in one step. So number of step is already given. So that means we have to use only one step and compare the answer with exact value. Okay, so here we have to compare the answer with the exact value also. So that means we have to find out the analytical solution and we have to find out the numerical solution. And then we have to verify whether the analytical solution is same as numerical solution. That means our method is going to be correct or not. Okay, so that's what we have to do in this example. So we go with the solution. Okay, so what we have here, let dy by dx is equal to x plus 3y with initial conditions x0 is equal to 0, y0 is equal to 1. Okay, and step x is going to be 0.1, h is going to be 0.1 because we have to find in one step. Okay, with we have f of xy is equal to x plus 3y. Okay, so these are the given things. Okay, so we have to find out this by Euler's modified method. Okay, so we can say by Euler's modified method, we have. Okay, so what is the predictor formula? Y1 is equal to y0 plus h times f of x0 y0. So it is y0 is going to be 1, h is going to be 0.1, and f. So f is going to be x plus 3y. So it is 0 plus 3 times y, y0 is going to be 1. So is it 1.3?
Yes, sir. 1.3.
Is going to be correct. 1.3 is okay. Are you getting this?
Yes, sir.
Yes, sir.
Okay. So we got this an approximate value. Okay. So this is the predictor formula. Okay. So this is going to be the predictor formula. Now we have to think of the correction for this. Okay. So now we have, okay, what we'll be having? The first correction to y1. So this is basically y1 and this is the number of correction. Okay. So first correction to y1 is y0 plus h by 2 f of x0 y0 plus f of x1 y1. Okay. So this is what the correction we have. And now hence we can write this as, see, this y0 is going to be 1. H is going to be 0.1. Okay, and this by 2. And then we have f of x0 y0. So f of x0, what is that? 0 plus 3 times 1. This is f of x0 plus x0 y0, f of x1 y1. So x1 is going to be 0.1 plus 3 times y1. Again, this y1 I am writing because we have to change only y. We don't have to change x0. We don't have to change x1. We don't have to change y0. So y1 will keep on changing, and that's why the quantity which will keep on changing is going to be variable, and that's why I'm writing this as a variable. So what we'll be having here, 1 plus this is going to be 0.05. Okay. Now what we'll be having, this is going to be 3. Okay, plus this is going to be 0.1 plus we have 3 times y1. Okay, so we can write this as 1 plus 0.05. Okay, plus this is going to be, this is 3 and 0.1. So this is going to be 3.1 plus 3 times y1. Okay, so now we have to write this equation. Okay, so it is the first correction to y1 is 1 plus 0.05 times 3.1 plus 3y1. Okay, so again I'll tell you how to write this equation. So 1 plus 0.05, then this is 3.1 plus 3. So you have to put the alpha button. Okay, then shift. Okay, and then you can see y. So what is how we get this y? You can press the simple fraction and decimal fraction conversion button after shift, so you can get this y. So your calculator display will display this equation as 1 plus 0.05, and this is 3.1 plus 3y. Okay, so once you get this equation, okay, then we can calculate further. So please get this equation on your calculator. You got this value? Got this
Yes, sir.
equation on your calculator?
Yes.
Okay. So even if you do not use this shift, that will also okay, because directly you can get alpha y. Sometimes you have to use shift, sometimes or some advanced calculator do not need it.
So it's 1.35.
Wait, okay. So you got this one, okay. Got this equation. So it is going to be
1.35 is the answer.
yes. Okay. So 1.05, and you have 3.1 plus 3 times y, and that's what we have. Okay. And calculate. So you'll be having 1.3. So you have to use 1.3. Okay, when you will go for calculate, so calculate, that means cal C, and then you have to put the value of y1. Y1 is going to be 1.3. So when you put this 1.3, you will get 1.35. How many of you are getting this value?
So getting same.
All of you are
Yes,
getting
sir, same
this
value.
value? Okay, so if all of you are getting that, that means you are going in a correct direction. Okay, so the second correction to y1. So what you have to do, just put press the button cal C and enter the new value or the recent value that we have obtained. Okay,
1.3575.
great. So how many of you are getting this value?
Yes, sir, same.
Okay, so you can see we have matched already 2 digits. So earlier we have matched 1 digit. Now we have matched 2 digits. Okay, so now we'll try for some more. Okay, and then you can see what is the value you are getting. So match with this.
1.358625.
Yes. So 1.358625. Okay. Then the next correction. So what is the next correction we have? 1.358625. So is it 1.358793?
Yes, sir.
Okay. So next correction. So you can see here we were having 86. Now we are having 87. Okay. 0.358793. So what is the value you are getting? 1.358818. Right?
Yes, sir.
Okay. So now you can check the sixth correction to Y1. Okay. So 1.358818. So what you are getting here? 1.3588. Are you getting this?
Yes, sir.
Okay. So Y1 7. So seventh correction. What you can have? So 1.3588.
So it will be 1.3588234429.
Okay. Yes. Good. Okay. So you can see here we matched 1 digit. Here we matched 2 digits. Here we matched 3 digits. Here again it was 3 digits. Here we matched 4 digits. And here we matched 5 digits. Okay, so we have reached to the accuracy 10 raised to minus 5. Okay, so expected from you is 10 raised to minus 4. So at least 4 digits you should match. Okay, and hence we can write here. So the value of y at x is equal to, what that we are considering? X1 is going to be 0.1. Okay, at x 0.1 is 1.33882. Because we are accurate up to 10 raised to minus 5.
So
Okay.
358.
Yeah, it is 35. Okay. So it is 35882. Yes. So that is y at 0.1 is equal to 1.35882. Okay. So we got this value. But our question says that we have to find accurate actual value also, exact value also. So you can see here we have got the value of y at 0.1 using Euler modified method. But we have to compare this answer with the exact value. So that means we have to solve this differential equation, find the analytic solution, and then we have to compare. Okay, so how we are able to do that? Then we have dy by dx is equal to x plus 3y. So I can write this as dy by dx minus 3y is equal to x. So this is actually the differential equation dy by dx plus py is equal to q, where p is going to be minus 3 and q is going to be x. So this is the linear differential equation with constant coefficient. So here we have constant coefficient, and the order of this linear differential equation is 1. So we can write the general solution, and hence we can write the general solution. Okay. So this I'll write equation 1. General solution of equation 1 is. So what is the general solution of this linear differential equation? It is y e raised to integration p dx is equal to integration q into e raised to integration p dx plus c, where c is going to be the constant of integration. Okay, and hence what we have here, so we got p is equal to -3, q is equal to x. Okay, so integration of p dx is equal to integration -3 dx, so it is going to be -3x, and hence e raised to integration p dx is equal to e raised to -3x. Okay, because integration p dx is going to be -3x. So we got here this term, and now we are able to write the general solution. So we get, what we are able to get is y into e raised to -3x is equal to integration e raised to -3x x, and this is dx plus c. You can see the value of q is going to be x, so we can write this. Now we have to solve this integral, so it is going to be integral x into e raised to -3x. So we know about the Light rule or ILET. Some people write it as ILET, okay, or Light. So algebraic first and then exponential at the end. So this is going to be exponential, this is going to be algebraic. So we have to consider the algebraic and exponential, and plus c. So what you have, this is going to be u and this is going to be v. So what we know is integral u into v equal to u remains as it is, integration of v minus, what do you know, the derivative of u and integral of v. So this is the integration by parts. Okay, this is what we have, integration by parts. Now what we have to do is we have to evaluate this. Okay, so let us evaluate. Okay, so I hope okay, this is equal to x remains as it is, the integration of e raised to 3x. So is it e raised to -3x by -3? Are you getting this?
Yes, sir.
Minus, we have to consider the derivative of this x. So the derivative of x is going to be 1. And then integration of this b. So e raised to -3x by -3 dx plus c. Okay, and that's what you'll be having. This is e raised to -3x minus, you can write here, this is minus x e raised to -3x by 3 minus this minus and this minus will become plus. So we'll be having 1 by 3. And again integration of e raised to -3x by -3. Okay, and you'll be having plus. So we can simplify this as minus x e raised to -3x by 3 minus, okay, we can have e raised to -3x by 9, and you can see plus. Okay, so what we got, the solution, we got y e raised to -3x minus, this is going to be minus x e raised to -3x by 3 minus e raised to -3x by 9 plus c. Okay, so that's what we got. Now let this equation 2. Okay, so what we know is, see the initial condition. The value of the constant c can be evaluated using the initial conditions. So we have the initial condition here. When I put x is equal to 0, y is going to be 1. Okay, so let us put this value in equation 2. Okay, so we call this as equation 2. So what we'll do is we'll put, okay, so we can have put x is equal to 0 and y is equal to 1 in above equation. Okay, so what we are able to get is if I put x is equal to 0, that means this e raised to minus 0 is going to be 1. Okay, so you got here 1. This is equal to. This is x is equal to 0. So this term is going to be 0 minus 1 by 9 plus c. Are you getting this value?
Yes, sir.
Are you getting this? Because if I put x is equal to 0, no, y is going to be 1. So this term is, if I put x is equal to 0, this is going to be 1 and y is 1. So that's what we'll be having. And hence, c is equal to, what you have here? 1 plus 1 by 9. So it is going to be 10 by 9. Are you getting this value? Are you getting the value of c?
Yes, sir.
Okay,
Yes, sir.
so that's good. So you got c is equal to 10 by 9. So we can say from equation we have, okay, y into e raised to minus 3x is equal to minus x e raised to minus 3x by 3 minus e raised to minus 3x by 9 plus 10 by 9. Is that okay? Because we can put the value of c, no? Are you getting this? Are you getting this equation?
Yes.
Okay. So now what I can do is I can remove this e raised to minus 3x and I can rewrite this equation as y is equal to, I am dividing this by e raised to minus 3x. Okay, so y is equal to 10 e raised to 3x by 9 minus x by 3 minus 1 by 9. Are you getting this equation? One thing is that either I can divide the whole equation by e raised to minus 3x, and when I write 1 upon e raised to minus 3x, it is going to be e raised to 3x by laws of indices. Okay, or either way, I have to multiply the entire equation by e raised to 3x. Okay, so you divide this equation by e raised to minus 3x, or you multiply this equation by e raised to 3x. Okay, whichever is easy for you, you can get this equation. So, have you got this equation? Have you got this equation?
Yes.
Okay. So, are you getting this equation? Okay.
Yes, sir.
So now, let this equation to be the next. This is going to be equation 3. Okay. And now, put x is equal to 0.1 in above equation. We get. So what we are able to get is y at 0.1 is equal to. So put and calculate and give me the answer. Calculate this value. The value you are getting?
So 1.35544.
Yes, 1.35539. 398. Are you getting this value?
Yes, sir. Same.
Yes, sir.
Okay. So you can see this is the exact solution. Okay, this is the exact solution. 1.355398. Okay, this will be the exact value at that point. Now you can compare the value that we have obtained. Okay, so what is the value we have obtained? 1.3588. Okay, so you can see the error again between the approximate solution, the numerical solution, and the exact solution. Okay, so the solution that we have obtained is accurate up to 2 digits. Okay, so the solution that we have obtained is accurate up to 2 digits because 1.35 is matching. Rest of the digits are not matching. Okay, so that's what we have. So have you got the idea how to solve numerically and then how to compare? Okay, because the given differential equation we have to solve analytically. This is called analytic solution. Equation 3 is going to be the analytic solution, the complete solution of the given differential equation. So this is analytic solution. So we got the analytic solution, and from analytic solution we have calculated the exact value, and from numerical method we have calculated the value at that point, and then we can see the difference between these two values. Okay, so we can claim that we can compare these two, and then we can see what is the error. So is there any doubt this example? Is there any doubt in this example?
No, sir.
So that's good that you don't have any doubt in this example. Okay, let us try to solve one more example. Okay. I hope you are able to see this screen. So let's go for another example. Are you able to read this question? Are you able to read this question?
Yes.
Okay, so we can go for solution. See, the question is use Euler's modified method to find the values of y, satisfying the equation dy by dx is equal to log of x plus y. Okay, for x is equal to 1.2 and x is equal to 1.4, correct up to 3 decimals by taking h is equal to 0.2. So h is going to be 0.2. So that means we have to use 2 steps. Okay, and given that y at 1 is equal to 0.2, y at 1 is equal to 2. So that is given. Okay, so here we need to understand the value of log. Okay, so here we use the value of log, okay, to the base 10. Okay, so when we go with the numerically, we go with the base 10. When we go with the analytic, we consider the log to the base e. So here we have to use the numerical base, and that is going to be the log to the base 10. Okay. So now let us write what is given. So we can have let dy by dx is equal to log of x plus y. So here we are going to use base 10. Okay. With what is the given condition? Y at 1 is equal to 2. So that is what we know, x0 is 1 and y0 is going to be 2. Okay. With what we have the function. Okay. And we have f is equal to, or f of xy is equal to log of x plus y. And here h is given. Okay, so h is given to be 0.2. So we can have by Euler's modified method. We have. Okay, so here we have to use the prediction twice and the correction twice. Okay, so please use your calculator. So y1 is equal to, okay, what is will be having y0 plus h times f of x0 y0. So this is going to be 2. Y0 is going to be 2 now. 2 plus, okay, h is going to be 0.2, and this is going to be log of x0 plus y0. So we'll be having 1 plus 2. Okay, and as I said, use base 10. So y1 is equal to, what is the value you are getting here? What is the value you are getting here?
Two 2.095.
0, 9. So here I'll put, not that, is base 10. So, okay, because then with this assumption only our calculation, we are going to do the calculation. So our calculation will hold. Okay, so what do you want here? This is
0.09542.
2.0954. Okay, so 0.9542.
4.
Okay, so this is the predicted value. Okay, and hence we have what will be the first correction? 2y1. Okay, so here what we get here? y0 plus h by 2. Okay, and here we have f of x0 y0 plus f of x1 y1. Please always write the predictor formula and corrector formula. Okay, so this is going to be 2 plus h by 2, so it's going to be 0.1, and this value. Okay, so what is this value will be having? Log of 1 plus 2 plus this value is going to be log of x1, so it is 1.2 plus y. 1. Okay, so you know this is going to be 1 plus this is going to be 0.1. What is the value of log 3? Is it 0.3010? 3020? What is the value of log 3?
0.477.
You are using base 10, right?
Yes, sir. Right.
Yes, sir.
Okay, yes. It is going to be 0.477121. Okay, because we are going with the 6 digit, and this is going to be log of 1.2. Okay, plus y1. Okay, so this is the first correction. So y1 1 is equal to. Now put y1 is equal to this one. Calci, place calci. How to get again this log of This is 1.2 plus alpha y. Okay. So you can get this as 2 plus 0.1 times 0.477 121. Okay. Plus log of 1.2 plus alpha y bracket. Please close the brackets properly, and you can say calci, and this is going to be 2.095424. Okay, so what is the value you are getting? Is it 2.099503? Is that correct?
Yes, sir.
Okay. Okay, so this is going to be the first correction. Okay, so you can go for the second correction for y1. Again, what you have to do is press calci and input this value. So it is 2.099503. Okay. So is it 2.099556?
Yes, sir.
Okay. So now you can see what is said, correct to 3 decimal places. Okay. So the first value was 0.0954. The second value we got 0.099. Okay. And so we got the next correction as 0.0995. So we have matched actually 4 digits. Okay. So require was 3 decimal places. We have matched one more. So that's good. And hence what I can write is, okay, so y at x1 is going to be 1.2, and the value is going to be 2.099556. Okay, so this is the value of y at 1.2. We can say since x1 is equal to 1.2. Okay, so we want at 1.4 also. So now we have x1 is equal to 1.2, y1 is equal to, okay, we got here, this is 2.099556, and h is equal to 0. So by Euler method, we can calculate y2, predictor formula. So what is y2? Y2 is going to be y1 plus h times f of x1 y1. Okay, and so this is equal to 2.099556 plus 0.2, and here we have, this is log of 1.2. Okay, plus 2.099556. Okay, so we are able to calculate the value of y2. So what is the value of y2 you have? You got this value you are getting here 2. Is that 203247?
Yes, sir.
Yes, sir.
Okay, so this is the predicted value. Okay, remember that this is the predicted value. We have to correct it. Okay, so we have the first correction. Okay, first correction to y2. So what will be the first correction to y2? y1 plus h by 2 f of x1 y1 plus f of x2 y2. Okay, this will be the first correction. So you got here the first correction of y2 is 2.099556 plus h is going to be 0.2, so it will be 0.1 here, and this is going to be log of 3. Okay, so how did I get this 3? So it is x1. So here it will be x1. Please be careful. So x1 is going to be 1.2 plus y1. So it is going to be 2.099556 plus this will be log of x2. So it is going to be 1.4 plus this is going to be y2. Okay, that's what we'll have. Okay, so first correction to y2 is 2.0099556 plus 0.1 and this term. Okay. So what you got here? This is log of 0.2 plus 2.099556. Okay. So this is going to be 0.518455 plus log of 1.4 plus y2. So you type this equation in calculator and then calculate this value. So this value you are able to get is C. Going to be 1 point, right. Okay, so this will be 2.09. So 2.099556. Okay, plus we have 0.1 bracket. So what do you got here? 0.051845 plus log of 1.4 plus alpha y, bracket complete, bracket complete. Okay, and then calculate. So what value of y2 you have to put? It will ask you the value of y. So this is the value of y2 you have to use. So it is going to be 2.203247. Okay, that's what we'll be having. What is all you are getting here? 2.207070. Are you getting this value?
Yes, sir.
Yes.
Yes, sir.
Okay, that's good. Now the second correction to y2. So again press Cal C and you'll be having 2.207070. Then you can get the value as 2.207116. Are you getting this value?
Yes, sir.
Yes, sir.
Okay, now the third correction to y2. Okay, so you can go with Cal C and then you'll be having 2.207116. Okay, and then you can get here as 2.207117. Okay, so you can see how many digits we have matched. So we have matched actually 5 digits. Okay, so here it was 3. Okay, here we matched is 5. So this answer is the most accurate answer. So this is it is going to be most accurate. So we can see here hence. Okay, so y2 means y at x2. x2 is going to be 1.4. So y at since x2 is equal to 1.4, so y at 1.4 is going to be 2.207117. Okay, so this is okay. So here we got for x1 as 1.2 and for y1 x2 as 1.4. So we calculated the x1 for y1 for x1 and y2 for x2. Okay, so this way we are able to use the Euler's modified method for 2 steps. Okay, so in the previous examples we have considered for 1 step. In this example we consider for 2 steps. So is there any doubt in this examples or in this method?
sir.
So is there any doubt?
No, sir.
Okay.
No, sir.
All of you got this method?
Yes, sir.
Okay,
Yes,
so,
sir.
that's good. Okay. So, for this method,